everyone, and welcome to our project on random number generators. My name is Dominguez,
Hello, I'm Salman Noori.
and let's jump right into it. So what is random number generation, and who cares about it? Well, random number generation is fundamental in digital applications such as cryptography, online gaming, video games, or any other application that requires an unpredictable result. The concept of true randomness is fundamentally tied to the human idea of fairness. So true randomness means that all outcomes of an event are equiprobable, and this concept served as the foundation to almost all popular games like poker, blackjack, and roulette that all rely on randomness to perform the game. So if you have to draw cards or roll dice or something like that, it requires randomness, is what we're trying to say. Replicating fairness in an online environment can only be done through RNG, and this means that online blackjack players wouldn't get angry if they knew that the house was manipulating the game. So you can see that's very important for fairness. What else is it used in? AI movement for video games is RNG. Song shuffling is pseudo-random. It's not fully true random, but we don't want to repeat songs in our Spotify playlist. And then it's also used in cybersecurity as well for things like password generation. So I'm going to hand it over to Salman now, who's going to be talking about modern RNG.
So we're going to talk about how the random number are generated in modern computers. Computers use the PRNG, or the pseudo-random generator, which produces sequences of random numbers that are predetermined but look random and can be reproduced and tracked back by knowing the initial number. This initial number is called the seed, which is followed by the sequence of the generated random numbers. There is the term period, which is the sequence of numbers that come before the seed is reproduced. In the next slide, we're going to talk about the method used to generate these sequences. One of the most used one is the linear congruential generator, the LCG, which uses this formula that we can see on the slide, which is the xn plus 1 is equal to a times xn plus b, all of that module m, where a, b, and m are large integers. Xn is the seed, or the current generated number, and the x of n plus 1 is the next generated number. And the largest number this method can generate is 1 less than the modulus, and this method has a much larger period compared to the next method, which is the middle square method. The middle square method uses the formula where we take 4 digits of the seed and we square that. It's a simple method, but it has disadvantages such as short period and poor quality outcome. But then this method becomes more powerful when combining it with the way sequence. And the last method we're going to talk about, which is the modern one and the one that developed to fix the errors and the older PRNG methods, is the Mersenne twister, which was developed in 1997. It's the most used one, and the name is derived from the fact that the period length is determined by the Mersenne prime. Next, we'll talk about some tests that are developed to check and test how truly random a number is, because there are so many ways of generating numbers, so there are so many tests as well. One of them is the visual test, which would be easier for humans to use, since they can follow this random walk, and they can see if there's a pattern to this walk. If there's a pattern, that means we can predict these numbers and they're not truly random. Otherwise, they're truly random. Another method used in the next slide is the information entropy test, which is testing what's the probability of the next outcome. So if the probability, as we see on the left image, if the next outcome has a higher probability than other values, that means the generated number is not truly random, and somehow we can predict what's the next value, which we don't want. But the entropy test, what we want is that each outcome has the same probability of appearing, and a high level of information entropy indicates that the data is randomly generated, and low level indicates that it's not. And one of the other tests in the next slide is called the frequency monobit statistics, which checks if the ratio between zeros and 1 and a random number bits is 1 to 1. If the ratio is 1 to 1 or close to it, then it's truly random sequence. And to do this effectively, the test will examine the stream of numbers as blocks. And if the ratio is off and not close to 1 to 1 between the zeros and ones, then that means it's not truly random for the block. And if a block is prone to failure, then it will most likely fail other tests as well. So now Dallas will talk about some important applications of these random generated numbers.
All right. So it would be a disservice to the craft to not mention the large part that RNG algorithms play in modern video gaming. So video games generate random numbers, typically from environmental variables like the console's internal clock, the number of objects on screen, or even the sequence of buttons pressed on the controller since starting the game. They've even been used in multiplayer or action-based games like first-person shooters, such as in what you see here, Counter-Strike Global Offensive, where RNG is used to determine how bullets hit targets at common engagement ranges. So, for example, let's dive into the statistics a little bit. A YouTuber by the name of Devin DTV did a video outlining the statistics behind the headshot accuracy of the rifles in the game at certain ranges, including the AK-47, which is important to note that some players swear by, and the M4. Shown below in the figures are the accuracy and measurement metrics for the AK-47 and the M4 tests. The algorithm used to generate the hit point within the circle around the enemy head hitbox is clearly pseudo-random. As if it were true random, all guns in the game would have the same accuracies, which is not something that we see here. There's clearly an advantage on the M4's part. So the algorithm is based on RNG and everything, and other extremely popular but non-shooter games that utilize RNG are games like Tetris, where each block is chosen randomly to keep the game stressful and unpredictable, Pokemon, where meeting unique Pokemon is random, Mario Kart, where the items you pick up are different each time, or Minecraft, where the world is randomly generated, and smaller details like the rarity of items or how many diamonds drop upon killing a mob are all random. With that being said, we want to thank you for this brief exploration of a bunch of topics of RNG. I want to thank you for tuning in, and we had a fun time doing this report, and we learned a lot. Thank you.
Thank you.